Please welcome Brett Bibby.
Thank you. Good morning, everybody. Welcome to Unite Singapore 2017. Super excited to be here. I spent 20 plus years of my career here in Southeast Asia making games. It's really great to be back. I got my nasi lemak this morning, my teh tarik, so I'm in really good shape. I'm ready to go. Assembled here in this crowd is actually a quite diverse set of creators. We've had a lot of diversity in our community. Many of you that are here are from our local community in Singapore, and some of you have actually come from around the region. Thank you very much for making the trip down. We have some indie studios here today, just getting started. We have established studios. We have programmers, artists, designers, producers. We have games, film, architecture, all represented here today. And so just want to give a very warm welcome to everyone. Thanks very much for coming. We're actually here. We're here this morning and for these next 2 days to celebrate you. We continue to be absolutely amazed by everything you do. And regardless how you define success, the installs of your games made with Unity in the last 12 months have surpassed 20 billion installs in 12 months. That works out, assuming I did the math right, 654 installs per second. 654 installs per second, every minute, every day, last 365 days. That's just absolutely phenomenal. And everybody is just dominating the charts. For mobile, the mobile set of platforms, which is the largest set, 40% of the top 1,000 games are built with Unity. And for new developments, games not released yet, that number is 50% and growing. It's just absolutely staggering. We're also together leading the charge on AR/VR with 60% of that content being built with Unity by our community such as yourselves, which is fantastic. Across all 25 plus platforms, you're creating some truly amazing experiences. Let's take a look at some of them. It's absolutely incredible. Every year we look at the show reel and it's just like, wow. And then the next year comes and it's like, oh my God, wow, a double wow. And the depth and the variety of stuff that's being created all by you, it's just fantastic. So thank you for that. In bringing you Unity and bringing you our work, we're inspired and guided by 3 principles. The first one is our founding principle, democratizing development. We live in the era of the creator, the maker, and creative expression is such a beautiful thing. whether it be writing, music, movies, interactive experiences, games. We believe the world is a better place with more creators in it. And everyone should have access to the most powerful creation tools possible. And together, we're changing the world. Our second principle is solving hard problems. And nothing much harder in this world than making interactive experiences. Doesn't really matter what you're making, though. It's just creative processes are hard. We strive to solve the hardest problems that stand in the way between you and your vision, allowing you to extend Unity and enhance it for your needs, enabling you to iterate rapidly, and increasing the reach to as many platforms as possible. These are just some of the problems that we're tackling every day. Our third principle is about enabling success. And we each define success a bit differently. It could be the number of people who experience your work. It could be the number of games, projects, or products you publish. It could be the number of dollars you make, your financial success. It could be getting the highest grade in your class. Or it could even be just the satisfaction of, I made this. We've been using our principles to shape and make what we bring to you. And we've done this with our latest release in 2017.2. 2017.2 was released a couple of weeks ago, and a big thank you to those that participate in our beta program, helping us make the software that we build as good as it can be. We continue to pay particular attention, though, to what matters most to you. First and foremost is our ever-increasing push for quality and stability, solidifying the foundation you rely on to build great products. We work hard on fixing the issues that matter most to you, and we've also invested very heavily in core engineering. We're going to be 500 strong by the end of this year. It's 500 engineers working for you. It's 500 engineers instrumental in bringing you 2017.2. Once you have a stable foundation, everybody wants the maximum performance and want the best they can get out of each and every pixel. And we're innovating and undertaking major improvements to Unity with incredible revolutionary results, which we're actually going to show you later on in this keynote. In terms of graphics, we've continued to learn since the release of Unity 5. With your feedback, we focused our attention on things like fast, flexible, iterative light mapping to keep you productive. We've got industry-leading post-processing effects, which you're going to see today, to make your content look great. And we're rebuilding our renderers to make them more scalable, more accessible, and of course, a lot more. You're never done on the graphics front. But all in all, we're going all out to bring you the absolute best platform-specific performant rendering engine that we can possibly develop. We also know that support for artists and designers is important. No longer a tool for just programmers with features like Timeline, Cinemachine, and the post-processing stack. We're giving artists the control of the creative vision they need and want, all without coding, and we're not done. We're making big improvements to creative tooling and the workflows, enabling the whole team to work better together. You can also count on us to continue to bring and provide industry-leading multi-platform support. We partner with over 25 great platforms to ensure timely and seamless integrations. Build once and with minimal work, deploy anywhere, enabling you to reach the largest audience possible. With big improvements to quality, stability, performance, and features, and a sizable engineering team working for you, 2017.2 is the most powerful engine and complete content toolset we've released to date. We're very excited to show you more, so I'm going to get out of the way and let some people come and show you that. Let's get started.
My friend Wes, who's a super brilliant technical artist, really wanted to put a constraint on himself. Using only asset store content to create the perfect image what he wants, the goal he had in mind. He brought in the content, and he didn't have to do any changes, just only moving around, but he didn't have to focus on creating something. Right? That allowed him to focus on the objects to make the image beautiful. On top of that, he applied the post-processing image stack, and there he really brought the volumetric lighting, the plume, even occlusion, and that allowed Wes to really wrap a prototype with using the asset store content, creating his own goal. Using the asset store for creative prototyping allows you to identify the objects you really want to focus on to create a unique project.
Please welcome Carl Callowart.
Good morning. I'm super excited to be here with you at Unite Singapore. We're all creators. We all have ideas of projects in Unity we want to create. We might have some content, but how do we conceptualize our idea to a final project? And we have those ideas daily. Our in-house artist, Wes, he had also an idea. And we're going to show you how he conceptualized his idea to a final result in just over 2 days. We like to call this project Neon. Wes, he started out with some content in the scene, but he really wanted to put a big challenge on himself. He wanted to create and focus on the final look and the result, to get to his final result basically, without spending any time on creating content, only using content he had. He wanted to see how far he could get in the project to get to that final look. So, we're going to show you how he did that. Let's look at the project we have here. So, it doesn't look much engaging. We see just a few props on the scene here. Okay. What we see is here a few cubes that Wes used to block out some things and to start to work in it. And when we look a little bit deeper in the scene, what we see is a whole scene packed with content that actually came from the asset store. Let's align the camera with the scene he had. It might look similar. When you take your own content or some package from the asset store, you put it all together, it looks flat sometimes. I have that same problem too. Okay. The first thing we can do is actually adding some light here in the scene. When we add some light in the scene, we're starting to bring out the shapes, the shading, and the contours. That gives it a primitive view of a depth of field. Okay, the perception, there's depth to it. When I talked to Wes, he said, well, when I start to create a prototype, the first thing I bring in my scene is the post-processing stack and the volumetric fog with the area lights. It's like having a bag of goodies to really get very fast the look and the mood into your project. It's like a must to have. Hey, let's explore those goodies, how Wes step by step got his final result. One of those goodies is the haven occlusion. Look, turn it on and turn it off. Turn it on, and we see a big difference. The haven occlusion will add those soft shadows in the corners and where the surfaces come together. Really bring that out, bring it more, giving it more depth to it. Another easy one is adding reflections by adding screen space reflections. Like, look here, turn it off. Look here at the puddles. And turn it on. Whoo! And nicely we see those reflections into the scene now. And screen space reflections is very good for puddles, wet surfaces, to bring that alive. One of the elements that has a big impact on the scene is volumetric fog. It has a huge impact in the scene. Fog, why do we use fog? Well, when we have an object in our scene, in real life, and it goes further away, it loses color. And normally we apply then fog in our scene, a linear fall off of that color of an object fading away. Volumetric fog really looks at the density of the scene and the contribution of the area lights in the scene. That's why you have those different variances in the scene here. It's not just a linear fog, it really brings it alive. Okay, look here. This is a really big impact. So let's tone down a little bit by adding here color grading and auto exposure. But the density of the fog is how much contribution of the air lights is in the scene. Like, look, if I bring it up, I get nicely that cyberpunk feeling to it. When I bring it to 0, well, we actually see almost little light in the scene. And when we tone down, it's basically the pure contribution of our direct light of the air lights in the scene. Let's bring it up again. And we're scattering those air lights into the fog. Let me go back to color grading. Color grading is so important. Some of you, some artists, really focus all their life on color grading to get the correct look, the feeling into your project. Color is so important. It's like light. It sets really the tone, the mood of your game, of your experience. Look, real time, I'm actually already changing the mood here. Right? Maybe bring a little bit colder in the shadows, bring a little bit warmer into the highlights. Real time, I'm changing this. This project is maybe not even finished, but I'm already defining right now the look and the mood of this project. And I can now start to communicate with my coworkers already. So they can start to contribute. Maybe an artist, a modeler, already starts to, oh, now I know how to model that object for this. Okay. Let's look at some other goodies to bring this scene alive. We have here bloom. Okay, adding bloom. So you see that's the feathering of the light of those neon lights in the scene. And we can actually animate this. Beautiful. Bloom, what is it? It's actually like a glow. It's when you look through the lens of a camera, look at that feeling, because lenses are never perfectly focused. And the small, really bright light really creates a bleeding of that light in the areas around it. Another one, to get that feeling you're looking through the lens, is vignette. Vignetting is the artifacts that the corner of the peripheral of your lens loses color, desaturation also. But it also helps us to tell a story, to focus on the center of your scene. Another one is here, to get that feeling that the language of the lens is aberration. Look, you see the corners here, the artifacts of the lens. We're going to bring this out a little bit, especially when you use super zoom, you can get those things. We add a bit of grain and a little bit drizzling rain. We get really the mood that we want in this scene. Are we adding here depth of field? And why are you going to play? Depth of field is an intelligent way to tell your story. It's really the point where there's a close, as far as in the scene, that you can define what is sharp there and not sharp. So here with that camera motion, and when we go down, we're going to tell the story, hey, focus on that little toy car. This way of creative prototyping can get you far away already in your project without having to resource of creating new content. And you can start to talk to your coworkers already on the look and the style, and everybody can start to contribute. Hey, let me show you a little bit more details in this scene. I'm going to take the camera and take it away from the animator. Look here, that's a nice example here. And we see those sewer systems, those pipes. And when you create a prototype, it doesn't have to be really a sewer system you're looking for. And you can break all the rules. There's no rules in creative prototyping. What is this object? Well, let's have a look. Let's find this object. Maybe you've seen it before. Well, it was not a sewer system. It was locked in the asset store as a ceiling, as a sci-fi ceiling. So this scene is full with those tricks of reusing assets just to get as far as possible in the scene before you have to resort to modeling. Okay, let's look at another example here in the scene. Look here, this is really cool. Wow. See all those cables? That's a lot of work. And when Wes was looking around, he went to the asset store because he really wanted to stick to his principle. And he typed in cables. He didn't find anything what he wanted. So he was almost thinking, well, I'm going to have to break the rule. But what is this object actually? Is it cables? Let's have a look. Anybody guess what it is? And there it is. It's a spaceship. Whoever thought you would take a spaceship for some cables? And that's the beauty of taking your own content, taking maybe some content from the asset store, put it together, and start to create a prototype. And it's pretty impressive that one artist can create a prototype with using some content he has, the post-processing stack, the volumetric light, and start to create his own feeling and look very fast so he can communicate with others. Communicate with others. Well, we showed this scene to Adam Minehill, who's our in-house camera specialist. And he was like, wow, I love this. I want to tell my own story in here. By adding an audio track, his own mood, and some animated camera shots. But he was also talking about, again, about the language of the camera. If something is off in the motion of a camera, we notice that right away. Because we've been looking through the lens of a camera by looking thousands of hours to movies and games. Cinema Machine and Timeline together, bringing that natural motion of a camera in a procedural way without having to keyframe, animate, program. Let's have a look at that. What we see here, neon, nothing changed. Here we have clips of cameras who are animated, a procedural animated cameras who will tell a story. Adam dragged here an audio. Okay, let's have a look of his own story in the same project. And we have here a procedural animated camera, and again, the depth of field to tell that story. And what we see is here, you follow a character procedurally. I'm following this camera on the left with a certain composition. All procedure done. I didn't have to keyframe, didn't have to script. Again, here that camera. I feel I carry that camera. Procedural noise, not even keyframed. Going from one shot to another shot procedurally, just blending. No keyframe necessary, and zooming in onto the character with depth of field. Again, the drone is a bit animated, but procedurally I'm following that drone. Here in that clip. Hey, this is Neon, nothing changed. Created by Wes. But let's tell a story in there. And let's end it with a certain mood. We're going to pull back the camera with a blurry and dramatic feeling to it. Now, how was that last part done? Let's look at that. Did we keyframe it? Did we have to do a lot? Oh, this is the beauty here. You can start to really create different clips and play around with it. Here, this clip. That's a clip where we added some procedural noise of a camera to it. Didn't have to keyframe it, just a component, and there we have it. This clip, look at that. The same, but we added a different post-processing stack to it, different settings to it. How are we going to keyframe this all? How are we going to do that? Look at that, super simple. Explore instead of keyframing. Look, I drag it over. That's it. Just drag it over the clip, and there I have the story I want. So the beauty is that you can start to create all those different clips and play around it, tell a different story. Hey, Adam made a different story here. Look at this. Let's mute this. We have a different one. He called it dark energetic. He got a different audio track, here the track, and some different camera shots. Let's have a quick look at that. All the different feeling. We're starting with looking at the spaceship and a different composition on the screen. Procedure following it. But how did that composition work? Look at this. Following that drone with a different composition. And pulling back and blending to a different shot. Again, we follow that character, but with a different composition and blending to a different state with image effects. Post-processing stack. So you see a different mood in the same scene. pulling back, blending between different cameras. Now, how that composition was done, let's look at that. It's phenomenal. Here. There's already a track here. You see that spaceship? I'll show you here. Click. You just make it visible. You say which object you're going to look at. It's visualized by a yellow dot. And now we're going to follow that. But look at the guides here around it. I can actually change that on the fly. And here I'm thinking, okay, here I have a certain composition, but later on I want a different composition. But it still nicely proceeds with tracking that spaceship. And that's how you get your own story and you move very fast. It's very inspirational. I think it's very amazing that one artist can tell a different story in the same scene using Cinema Machine and Timeline. So, using content you all have, you can get very far to the look and the mood you want. But of course, we're all going to use our own content and create new content to that. At Unite Austin, we announced our partnership between Autodesk and Unity. It's pretty cool because Unity 2017 is the first game engine to have access to the FBS file format SDK. Now we can create a streamlined pipeline between Maya and Unity. Think about that. You as an artist, you can create something in Unity and bring it into Maya, change it, bring it back. You can be part of that creative process right from the beginning. And let me show you a movie file. How it's done. Okay, I got a cube in Unity, I put it there, but I want to start to change this. I bring it in Unity, I bring it in Maya here, I can edit or swap it with another model that somebody else made. Got a spaceship here. Now, I can add a stingray shader to that too. And as an artist, I'm tweaking here my reflections, tweaking my glossiness, all that information, guess what? It's in Unity directly updated. All that information goes back and forward now. Okay, in Unity I'm working on it. I might be adding a collider to that, a box collider. But if I go back and forward, I don't want to lose that information. I want effective work together. So go back here, do some changes. I find my spaceship doesn't fly fast enough, so I'm going to add some wings to it, do changes. When I save this now, bang, right away into Unity, updated. Awesome, eh? Yeah. Neon is a true inspiration for all of us. We as creators, you all have content. Bring the content in Unity, maybe create some new content, use the goodies such as the post-processing stack and the volumetric fog to create your look and feeling for your own game. Look, all I'm asking is, if you create something, I would love to see it. Thank you, and see you soon.
Thanks, Carl.
Thanks, Brett.
When I saw the Neon demo for the first time, I was blown away, not because of the final result, but it was like, it popped into the Unity scene, and it was like very plain and dull, and I was like, wow, that's just like my scenes. But it was great because it shows how easily now you can go from meh to wow, you know, and I really like that. As mentioned earlier before, we're here because of you, and your passion to create and to innovate inspires us at Unity every single day. And it's stuff that we share internally all the time. And your stories especially fuel our passion. And we've collected some of those from Southeast Asia this morning. Let's take a look.
What inspires me the most is the ability to create experiences that make people smile and kind of brighten up people's lives. That's kind of the reason that I make games.
What inspires me? Different things, a lot of cool things. It could be games, it could be graphics, it could be art, illustration, it's anything.
We've been using Unity on and off for about 4 years, and we're currently using it to make an MMORPG on mobile, so it's a very ambitious project.
The moment when I got my first computer at age 12 was the very moment I fell in love with programming, and I knew that I wanted to do that for the rest of my life, which eventually I didn't because I moved from programming to running a studio, but that's my story anyway.
The most challenge that we are having in the game industry in Indonesia is mostly because game industry is quite new and we have lack of talent and experience.
The biggest challenge I have had to overcome is balancing the time for my job and my family. I spend too much time in my job.
I mostly enjoy coming together and throwing ideas with my designers, with artists and programmers. So everyone has their own ideas about how to make something really good.
What I love most about the creative process is that it makes me feel alive. It's like, yeah, I'm here on Earth. I lived once. This is what I did.
I think people love immersive experience because it feels like we are in the different world. Yeah, where we always have our routine days, but with the immersive experience, we can become anything we want.
I think immersive experiences allow us to escape reality and explore new worlds where we can try different kinds of things which we couldn't try at all if we had to only live in the reality.
My favorite title would probably be Pokemon.
My favorite title of all time, and I'm going to date myself, it is Sword of the Samurai by Microprose.
Manga ấy, thì tôi muốn họ cảm nhận được cái sự trẻ trung và những cái liên quan đến truyện tranh mà họ yêu thích, và tập trung vào nhân vật.
When people experience my game, I want them to feel fun, interesting, and I want them to feel like they live in our games.
I love building things.
I create because I like to make people smile. Games gives people a sense of escapism and makes their lives a bit brighter.
Listening to stories like this really is amazing. I mean, at Unity, we don't make our own games, so we sort of live existentially through you. Thank you for that. You know, if you see me around in the next couple of days, come get me. It's really my favorite part. You know, share your stories with me. We're going to shift gears a little bit right now. Unity has been steadily improving our 2D tools, and that work is actually being done right here in Singapore by our Singapore Unity R&D team. Let's take a look at what they've been up to.
For the past couple of years, we've been really hard at work on foundational 2D features at Unity. This is an important area of focus for us because even though we want to work on the high-level features, we want to make sure that they're built on a strong foundation. We're really excited that this year we've completed most of that work, and we're ready to switch gears and release the first of our 2D layout tools. This is TileMap, which we're releasing with 2017.2. This is a tool for building grid-based layouts in games. I personally feel really strongly about this tool because I can see artists and designers using this tool to express themselves in Unity and literally paint right in the scene. Another thing that's new is Cinemachine for 2D. Now this is going to bring all the power of procedural cameras to anyone making 2D games. This way, you can focus on tweaking your cameras and stop writing code.
Please welcome Russ Scammell.
Hello everyone. It's a real pleasure to be back at Unite Singapore. It's been a really good year for 2D at Unity. New with 2017.2, we are introducing TileMap. So this is our solution for grid-based layouts in 2D games. And it comes with a TileMap Collider 2D. This is to help you create collisions for your tile maps. Now earlier this year, we did some work on some really important features as well. We released the Sprite Atlas asset, as well as the Sprite Mask component. We also did some work in sorting. We released the sorting groups, as well as the axis distance sort. And this is to help those of you making 2D games with the tricky problem of sorting in 2D. Also, new with 2017.2, Cinemachine for 2D, where we've added a number of new features which makes this a really powerful 2D camera system. Now we're going to see these features in action using assets from a game by Epic House Studios. Phased was one of the first games to be built on our new tile map feature. This is a unique Made with Unity title that really makes creative use of pixel art and glitch effects to tell the story of their main character, a girl who wakes up to discover that she has the power to twist reality. We really love how they've embraced the vintage kind of throwback art direction, but they've also added some sprinkles of modern techniques like chromatic aberration and distortion buffers for their effects. We'd like to thank the awesome team at Epic House for letting us use their assets for this demo. I'm going to start by building a level from Phased in TileMap. So TileMap gives me this really smooth workflow for importing images that I've prepared in my art authoring tool. And I can just bring these into Unity as sprites, which I can then drag onto my tile palette here to prepare tiles. These are now ready to be painted onto a tile map in the scene. So I'm going to start by painting the walls of the level. And to do this, I'm going to use a custom tile. Now, a custom tile, in this case a rule tile, we can see in the inspector here, this allows us here to create relationships between neighboring tiles. So maybe you want to, when you're painting in the scene, you want automatic corners or edges. And this depends on what the tiles next to you are. Now you can create your own custom tiles by extending the tile class, of course. But we wanted to get you up and running quickly. So we provided a set of custom tiles and custom brushes as part of our 2D extras package. OK, so let's grab this tile and start painting. So I'm going to come in here, and first of all, I'm going to make sure I'm on the walls tile map, and I'm going to select a tile in the scene from the tile map. And then I'm going to just start painting directly in the scene. There we go. You can already see the automatic corners and edges coming in. I want to go a bit faster, so I'm going to use a box fill tool to finish up the rest of this level. OK, that's looking pretty good. It's a little bit empty, though. I'd like to add a bit more color, and I want to work with some layers. So this scene has been set up for exactly this purpose. We're going to use multiple layers of tile maps and get that kind of layered effect with all the different assets in the scene. I'm going to do this with some posters. Okay, so let's put some posters on the wall. On another tile map, I'm going to put down first layer. Let's put some posters here. There we go. And then on yet another layer, I'm going to select another tile map. I'm going to put down yet some more posters, right? Now this is kind of fun. I want to keep going, and then I'm going to talk a little bit more about how all of this stuff works together. So on a furniture layer, I'm going to put down the bed. I really like how I'm just working right in the scene. This is really fun. And then I want to put a room divider over here. OK, cool. And then I think we need a door, because otherwise our player is going to be stuck in here forever. OK, done. Now, all of these tile maps are just working together, right? They're just seamlessly sorting, and we're doing this using sorting groups as well as sorting layers and order in layer. Now, you may want to add just normal sprite renderers as well, so I want to show you an example of that. OK, so here we've got the same room, but we've added a fan, if you look in the middle of the room, as well as a tiny alarm clock on top of one of the bedside tables. Now, these are normal sprite renderers, and again, they just work seamlessly with your tile maps. Now, so far, we've seen tile maps that are purely aesthetic. We're just using these for visuals. But you're making games, so you're going to need to do something to prepare for gameplay. And a typical thing that you want to do is to add a collider to one of these tile maps so that when we put the player in the scene, she doesn't just fall through the floor, right? OK, so what I want to do is I want to add a collider to the walls. And I just do that by selecting the walls tile map here and turning on the tile map collider 2D. Cool? So as you can see, that's a really nice fit for the edges of the wall. And the reason it fits so well is that we're actually taking the physics shape data from the sprites that are being used in these tiles. Now this works really well with the Composite Collider 2D. If I were to turn that on, we can see that we have a optimized collision mesh now, right? So that's going to run a little bit better in your games. Now game design is a fluid process, right? You're going to be making this level, and then you're going to go, hey, you know, I want to make some changes. I want to adjust something. Or maybe your art director will come to you and say, hey, make that ceiling higher, right? And then what are you going to do? So if I come here and I go to the walls tile map and I make changes, so here I'm just going to make it a little bit higher. Let's make the ceiling a little bit higher. We can see the tile map collider just adapts automatically, right? So this is really cool. It's a very flexible system. Right. Let's put a player in the scene, right? Let's complete this. Let's put our player in there, and let's hit play. Now again, this is just a series of animations and a game object and some scripts to help her walk around. And you can see that all the different layers are just playing really well together, right? And she's not falling through the level, so that's good. Now, it's Halloween season, right? And I thought it would be a good idea to add a little bit of a festive spin on the level. But I want to give myself some constraints. I don't want to redeploy my game, and I don't want to make my users download a new version. And I want to do it only for my players in Singapore, right? I want to test it with you guys first before we share Halloween with the rest of the world. Now, there's an improvement in the new analytics remote settings that will help us do this, and this is segmented remote settings, which we're going to take a look at now. So we're on the analytics dashboard, and you can see I've got a variable here called isHalloween, right? And at the moment, it's false for everyone. What I want to do is I want to change this value here, and I want to make it true just for players in Singapore. Now what's new here is the segments, right? So I've made this true for only those users who have their country set as Singapore. You can do this for your iOS players or your Android players. You could do it for different monetization tiers or other metrics that you want to segment your audience by. So I'm going to synchronize this. Okay, we're going to wait for that to set. And then back in Unity, so let's keep in mind, we've made no changes at all to this level. And we've just changed that one variable. I'm going to hit play. Oh, there we go. And it's Halloween in the world of phased, right? And you did this without having to redeploy anything. You're updating your game after launch, which is cool. Now you can use this to roll out new features, new gameplay features, gradually testing them in different segments. If you use it with standard events, you can monitor the impact through the analytics dashboard. Overall, you can test your creative ideas, right, and your new designs and make your game more fun. Okay, I want to switch gears a bit. I want to explore a larger level in phased. Let's take a look at the town from phased. I'm going to hit play here. So we can see that it's a much larger level. There's a lot more interesting things going on. And I would really like to walk up and down the street and explore the world a little bit. But I don't have a camera. I don't have a follow camera, right, on me at the moment. So this is a good time to talk about game cameras. So game cameras end up being these really kind of unwieldy balls of code, right? You start off with a simple idea. You're like, hey, I want it to follow the player, but then in special situations, I want this behavior or this behavior. And every change you make is a new piece of code that you have to write, and they don't often blend together well. Tuning and iteration becomes slow, and you end up stuck with this really messy system. Now with Cinemachine, you get smart cameras that follow your direction, right? And they quickly make it really quick and easy to add new behaviors to what you're doing. I want to add one of the new 2D cameras from Cinemachine to this level. And to do this, all I have to do is come in here and do Create 2D Camera. So I'm going to select that, and look in the game view, you can see we're a little bit too far away from the level right now, so I'm going to zoom in a little bit and turn down the orthographic size. Something like that will be good, I think. I'm going to tweak a couple of other values here. We'll come back to those. And then, of course, we want it to follow the player around. So in the follow field, I'm just going to drag in the player. I'm going to hit play. And in just a few clicks, we've added a follow cam. And this works really nice in 2D. Now, I want the movement to be a little bit less mechanical. Yeah, I want to add some tweaks to that. So the first thing I want to do is I'm going to increase what's called the dead zone width here. This is the space, the width in the game where the player will move, but there's a bit of tolerance, right? The camera's not going to move while the player is within this space. So I'm going to hit, yep, that's about right. And then when I hit play, you can see the camera only moves when we hit the edge of those bounds. I could be making those tweaks in the game as well, like this, right? Which is kind of fun. I also want the following to be a little softer. Okay, so let's increase the damping here. All right, so now when I hit play, you can see that the camera is lagging ever so slightly behind the player. Now, you may have noticed something else I'm doing. I'm making all of my changes in play mode, right? And this is a critical point. It's a vital workflow, actually. For artists and designers who work with cameras, they realize that these are living systems. And when you're making your tweaks and changes, you need to do it in the game to understand how it's affecting the perspective, how it's affecting the dramatic quality of the game. And because we have a save during gameplay checkbox here, all of those changes that you've made are going to persist when you go back into your editor. Okay, I'm going to look at one more thing. So over here, if I keep walking to the left, there's a little section with a stack of TVs, and there's going to be a little exposition here. We're going to tell you a little bit about the story of Phased and what you're doing there and what's going to come up next. And what we've done is we've added a little zone there so that as you enter the zone, it hits a trigger and we enable a camera. Now, because this is Cinemachine, when we enable a new camera, if it's a higher priority or the same as the current one, we blend our settings from the current camera to those. So let's see how that affects things. See, that's very nice. It's a small change in the behavior, one camera being enabled, but it changes the dramatic quality of the scene. You're being drawn into the world, and you're being told that there's a party that you've got to check out. Right? Suddenly that's an important thing. And there you are. I'm really excited about TileMap. I think it's going to be really fun to see what artists and designers using custom tiles and custom brushes are going to do when they can express their creativity directly in the scene. And with the Collider, that gives you a great way to make grid-based layouts for your 2D games in Unity. Now, with remote settings, you can update your game after launch. You can test that on different segments and really make the best experience for your players. And with the new segments, you can test this on different segments as well and create different experiences. With Cinemachine for 2D, we have all of these really exciting new features and all of the features you've come to love with Cinemachine, but now in 2D. So you can spend your time creating cool cameras and not writing code. So with 2017.2, Unity now has a great end-to-end solution for 2D games. If you'd like to find out more, I'm giving a talk on this and all the new 2D features on track 3. That's on Friday at 11 a.m. Thank you very much, everyone.
Thanks, Russ.
Hey, thanks, Brett.
It's amazing how easy 2D is becoming in Unity. And prior to that, we saw Carl's Neon demo and how Unity gives content creators the ability to iterate their creative visions rapidly. Before that, earlier on, I talked about, in the performance section, Unity as innovation and the revolutionary stuff that we've been working on. So I think that it's time to take a peek into the future of Unity.
When we started Unity, our focus was on building a game engine that is simple and easy to use. By doing that, we enabled more developers to create games. We achieved our goal. Over the last couple of years, our focus has been on how to bring Unity to the next level of performance. When your game has great performance by default, you can use that to create richer worlds, have more complex simulations, or simply run on more hardware, thus reaching more users.
Please welcome Jay Santos.
Good morning, everybody. So we have all had great ideas for a game, launch Unity, and start putting game objects on your scene, game object after game object after game object, and when you realize you have hundreds of game objects on a scene. Now, for most of the games, Unity works very well. And of course, we're always getting better at it. But there are the outliers, the use cases that need extreme performance. And of course, we work on those too. Today I'm going to show you key ways that will enable you to achieve such high performances. And of course, to do that, we need some content. For that, we partnered with Nordeus, an indie development company from Belgrade in Serbia. And they're developing a mobile game called Spellsouls, Duel of Legends. When we first approached them, they're super excited about the new features, and they helped us create a showcase for these performance improvements. And to build the showcase, we used some of the assets of Spellsouls. So now, let's check the intro and then jump right into the editor. All right, so here we have our battlefield, and as you can see in the top right corner, we have around 8,700 units on our scene. And there's a lot going on. If we zoom in, you can see here that we have a skirmish going on between the Red Army and the Blue Army. And you have here, if you go to the other side, you have the archers lobbing arrows. And it seems like the Red Army is in advantage. Let's give the Blue Army a hand here. There you go. And there. Oh, look at these guys here. Let's zoom in. This one is my favorite. There you go. So see, you know, it is pretty crazy as it is. But what if we make it even more crazy? Let's ramp up the number of units in our game all the way to 70,000 units. And now, right now, we have in our scene 70,000 unique individual units doing what they're doing, and we're still maintaining a 30 frame per second constant frame rate. So this is pretty impressive. Now, there's a lot of things going on here besides what we've already shown. Each one of these units have to decide animation, have to do rendering, they have flocking, they have pathfinding. So they have pathfinding not only for all the platoons, but for each one of the individual units composing the platoons. And they have to decide when to use the attack animation, when to use the walk animation. So there's a lot going on here besides the battle itself. And of course, I can, even now, just throw a whole lot of magic effects here. And we still maintain the constant 30 frames per second, right? Look at this one. This one's going to be nice. Let's see. There you go. You know what? You guys enjoy Unite Singapore. Go to the talks. I'll be here having fun. If you need me, you know where to find me, okay? There you go, another nice one. So anyway, let's focus. Let's get back to the presentation. Okay, so how do we achieve this performance, right? We achieve this performance by using 3 new pieces of technology. The first one is what we call the new C# job system. So I'm going to go out of my game and jump into the profiler to tell you more about the job system. So let's stop recording here and get a frame. Let's go to timeline. And once again, on the right side, you can see the several worker threads running on each one of our CPU cores, right? So each one of these threads is running several jobs that work on each one of the tasks I mentioned: navigation, animation, rendering. So if you have a look here, you can see like this job here called search closest formation. So this is pretty much individual units looking for the closest platoon to join. Now, I want you to pay attention at the name of this job. It has burst right after it, between parentheses, right? Keep that in mind. We're going to talk about burst in a second. And we have several other jobs here. We have minion behavior move job, etc., etc. And we also have this execute raycast job. And one cool thing is that you can schedule job executions. So the execute raycast job is scheduled to perform at every given time. So you can see that it's executed here, and here, and here. And this is all running at 95% CPU occupation. So this means that you are squeezing every last drop of performance from your CPU. Now let's talk about the second new tool, which is the Entity Component System, or ECS for short. Now, ECS allows you to work with hundreds and hundreds of game objects in a really fast way, instantiating, updating, destructing, altering, without loss of performance. So let's remember how we've seen that in action in the demo. So we've seen the archers lobbing arrows, right? And they're lobbing hundreds and hundreds and hundreds of arrows, and without loss of performance. And this is all thanks to ECS. So what ECS do is that it collects all the similar data at once, in that case from the arrows, and optimize the data cache coherency. What does that mean? That means that you have a significant speed up of performance on your CPU, and that's the most efficient way to write your game logic. And finally, the third piece of tech I'm going to talk to you guys today is the burst compiler. Remember that when I showed the job to you guys, there was burst between parentheses. That meant that that job was created using the burst compiler. Now, the burst compiler was created specifically to work together with the C# jobs. And what's special, so to speak, about the burst compiler, that it is a math-aware compiler. That means that it looks for higher math functions after your code is compiled and optimize these functions. So think about it as Microsoft Word's Clippy less annoying, and actually achieving something. So in order to understand what this means to you, let's compare results between our current compiler and the Burst compiler. As you can see, we have significant improvement in performance, between 3 to 13 times. So that's incredible. That's going to bring you a whole lot more performance. Now, you might be wondering, how do you use these technologies, right? So let's talk about each one of them. So the job system introduces some new concepts. It's going to take you a while to adapt, but nothing longer than 1 or 2 days. And the cool thing is that we are creating it to be very friendly to the user, to really take your hand and walk you through the process. So you're going to have quality warnings explaining to you what you're doing and teaching you how to use it correctly. So it's going to be super simple for you to adapt to the job system. The ECS is the same case. It's going to take you some adjusting, but once again, nothing that's going to take longer than 2 days. And the ECS is really going to shine on your game on cases where you have, once again, hundreds of objects at the same time on the screen, like the arrows we were lobbing, right? This is where the ECS is going to bring you benefits. In the single house, and a single town, and a single scene, the ECS is not going to be that great, but once again, when you have pooling objects, when you have several instances of the same object on your scene, that's where ECS is going to do its magic. And finally, the compiler, that one is 100% transparent. All you need to do, use Unity, you're using the new compiler. And now, the question that you all have in your mind, when will this be available, right? So, I'm glad to say that C# Job System and ECS will be available at Unity 2018.1, coming up early next year. The Burst compiler is coming up a little bit later next year as well. Okay, thank you so much for your attention, and I hope you guys have a great Unite Singapore. Thank you.
Thanks, Jay.
Thank you.
Fantastic. Very exciting to see what we have in the pipeline, and it's just a couple of examples of us trying to solve hard problems, enable success for everybody. We're just about done. To kickstart the conference and sort of put us all in the right mood, we actually also put together a showreel of projects from the Southeast Asia region, and we thought we'd take a quick look at those. Let's take a look. awesome work being done here in Southeast Asia. You can check out these demos and more over at the excuse me, Made with Unity showcase in the Art and Science Museum. Thanks again for coming to Unite Singapore. We're done. The conference is now open. You can proceed directly over there and have a great 2 days and enjoy the show.